Welcome, everyone. My name is Kumar Venkateswar. I'm a program manager in the Online Exchange Server team. I was formerly a product manager in the Office 365 team, and the topic that I'd like to talk to you about today is something that I think is really essential to our service and something that we have to get right, and I think we have gotten right, which is service reliability and disaster recovery. The reason I say it's something that is essential is because no matter what functionality we have in the service, if it's not up and running a great deal of the time, if not all the time, you basically have no productivity, and there's no point in any of the things that you've designed. So I feel very, very passionately about this being one of the most important topics, and I thank you all for coming. So I'm going to take a little bit of a different tack than some people tend to expect for this particular presentation. And that is, I'm going to talk about some of the underlying principles that we use to design Office 365 for reliability and predictable delivery. And the reason that I do this is because Office 365 being a service that we're offering tends to change in the way that we've implemented some of these design principles. So if I talk about things in terms of how many of you are familiar with Exchange, work with Exchange on a regular basis? A lot of you. So supposing I talk about a multi-site topology, and I say, we've designed things so that they're in 2 different AD sites. That may be true today, but there's no guarantee that that's going to be true pretty much the next time I deliver the talk or when you guys go back on your flight. It's not guaranteed that that's going to be true, where the architectural principles that we use are fairly constant throughout the release, and we try to make sure that we have an efficient implementation of them. The other thing that I'd like everyone to take away is an understanding of all of the information that we provide before, during, and after service availability interruptions, so that you understand what to expect in terms of communication. It's not just important to have a service that's up and running, but whenever there's an outage or we expect to have an outage, there's planned outages, things like that, we strive to make sure that we're communicating and we're as transparent as we possibly can into the cause, where we are in terms of solving the problem, where we are in terms of restoring service, so that we can set expectations for you, you can set expectations for all your end users, your customers, and we think this is super important, almost as important as keeping the service up in the first place. I also want to describe how we go through the process of this continuous improvement. So we have a cadence of regular improvements that we make to the service. It's a faster cadence than you would typically expect for on-premises servers, and I want to describe a little bit of that. The picture around availability, typically the things that you get in the press, the short stories that you get, are usually centered around the numbers. Is it 3 nines or 4 nines, 5 nines, things like that. But I mean, I'm sure all of you know, as people that run servers, it's more nuanced than just the numbers themselves. You can have a server that's up and running, but it may not be providing all of the functionality. And just because it's running on paper doesn't mean that it's fulfilling what you expect from the server. And the same is true with services. So what we believe is that we've come up with a way to provide end-to-end reliability with a thoughtful product and service offering between Office 365 and the Office software stack. So because I'm sure everyone loves to see the number, I'm going to talk first about what the uptime is and what we've seen over the last year. We basically beat what you would expect to be our aggregate SLA number. Note that this isn't the number that any particular customer would get from their SLA. They probably get a higher availability, but the aggregate availability for across all of the customers that we have has exceeded what we would see from an individual SLA. So kind of getting that number out of the way, we'll talk a little bit more about how to look at that number and how to understand that number in terms of what it means for your organization. But we also should take a little bit to understand why we see that type of number in Office 365, what we do, what Microsoft does in order to make sure that you're seeing that. So it's important to note that Microsoft is not new to this business at all. We've got years and years of experience running infrastructure at high scale. You don't think about Windows Update as a particularly prominent service, but it's over 500 million PCs that are connecting to it. And that's one of the largest services that you have anywhere in the world. You've got Hotmail, which is upwards of 350 million accounts. Bing MSN Search, which is also upwards of about 350 million unique users. Xbox Live, I believe the number that we announced is over 40 million. And Exchange-hosted services, including Forefront Online protection for Exchange. All of these are upwards of tens of millions. And Office 365 is in that order of magnitude. We've got years of experience running these. I mean, you look at Windows Update, it's back from 1995. And we've utilized the expertise that we have in terms of designing data centers, designing the network connectivity to those data centers, and so on. We've brought that experience to Office 365. So to kind of be a little bit academic, the way we think about resilience, there's several ways that we can provide resilience within this system. And one of the ways, of course, is to anticipate the kinds of problems that you may have, and we do a little bit of that. That's a good thing. You can anticipate it and then avoid it. The other thing is to be able to absorb it. So if there's some sort of spike in load, for instance, if it's Mother's Day, people emailing a lot, or Mother's Day people are calling a lot, you can absorb that by designing in excess capacity. So in order to prevent the service from falling over due to load, you can design in, you can say, we're under normal circumstances, we're never going to exceed 40% CPU utilization. The other ways you can do it is you can reconfigure the service. So the service can automatically reconfigure itself and redistribute the load. So for instance, if you have back to school day, there's a lot of traffic that comes to educational institutions, but not to other institutions. So you can reconfigure things so that more resources are spent towards the educational institutions and less towards the other ones because they don't need it at that particular time. And then the last is, of course, to restore service. So you take whatever actions you can to restore service once you have an outage. But of course, that's the least desirable way to address resilience. And to do these, we have a lot of design heuristics that are well known, and we can go into how these design heuristics are implemented within Office 365 as well. So one important principle that we follow in Office 365 is the principle of functional redundancy. So one example that we have of this is online and offline functionality, such as that provided by SharePoint Workspace or Outlook. And we call this functional redundancy because there are two different functional paths that are followed depending on what resources are available at the time. So if Outlook is online, and you're trying to send a message, it'll connect to the server, transmit the message, and it all will be good. If you're offline, on the other hand, it saves it to the outbox and then proceeds to go through this similar path once you've connected online. So because of this functional redundancy, supposing you have a Wi-Fi outage like earlier in the week, you can still have a productivity experience in spite of the fact that you've lost part of your system. Another example of this is in network connectivity to the data centers. So how many of you run data centers with multiple networks? So there's a few of you in the back. Of those people that run multiple networks, how many of you use different providers? So almost all of you. If you strictly follow the principle of physical redundancy, you would have two networks that are going to the same provider. And if that provider has an outage, you're vulnerable to that outage because you have this common path in terms of that provider. If you're trying to provide a functionally redundant path, you would actually have two different paths to two different providers. And again, this is one of the principles that we follow in the design of Office 365. We also follow the principle of physical redundancy. So it's resilient to hardware failures. For instance, all of the data is stored on multiple disks, and this is data in transit and at rest. So if we have, most of you are familiar with Exchange, you've got the concept of shadow redundancy. So if a message is received by a transport server, it doesn't acknowledge that that message has been received until that message has been saved onto the mailbox server. And that's one of those principles that we follow to make sure that we have physical redundancy of the data, both at transit, in transit and at rest. And in that case, it's at least 2 copies of the data in order to make sure that there is no chance of failure. In other cases at rest, there may be more copies than that, but this is one of those principles that's followed. Another layer at which we have that type of redundancy is network hardware. We also have redundancy in terms of the data center facilities and power redundancy. So each of the data centers that we have has multiple power sources, and each of those data centers has mirrored content into another physical data center, and there are at least 2 data centers per region. You would think normally the way these data centers are designed that you wouldn't really need data center level redundancy. And that's something when I was working in the Exchange team, I was somewhat questioning the necessity for having redundant data centers because the data centers that Microsoft uses are typically things like, in the Washington area, we've used old Boeing factories. And these are giant buildings that are used that can withstand, class 5 hurricanes and serious natural disasters. And there's very, very few disasters that can take out a data center of this kind. However, after I was thinking that and was discussing with the team about the necessity for doing this, we actually had an outage in Ireland. We had a data center loss in Ireland that affected not just us, but multiple cloud providers that had their data centers in Dublin. And there was either a lightning strike or some sort of power outage that took out a transformer, and that transformer fed back and took out multiple power supplies and the hardware that was used to fail over between the power supplies. And this freak accident ended up taking out an entire data center, even though it had redundant power sources and a backup diesel generator. They were not able to bring any of that online. And because Office 365 has multiple data centers, they were able to fail over to a different data center and continue operating. So we follow not just the principles of physical redundancy, we also follow functional redundancy. Another case in which these two played together is we had an incident where we acquired disks from a particular disk manufacturer in a particular batch. And we had those disks deployed throughout a database availability group. And what we didn't realize at the time was that the failure mode of these disks would be that they would fail in a particular period of time. They would fail catastrophically. So what ended up happening was we had all of these disks from the same manufacturer. You wouldn't think of this as normally an issue. When they failed at the same time, they ended up taking out multiple copies roughly at the same time. Like within the same week, we had multiple copies of the data being taken out by that. A way to mitigate that circumstance is to mix batches of disks, to use disks from different manufacturers, and to try and come up with a more reliable mix so that the failures for those disks are not as correlated as they were before. And this is the kind of thing that we don't necessarily realize when we first design the system, but as we run the system more and more and with more and more people, we get to this point where we can operationally implement some of these principles in a way that we hadn't before. So in this case, you'd have to mix disks. You'd have to mix disks of different ages, mix servers of different ages, mix servers from different manufacturers in order to provide not just physical but functional redundancy. You had a question?
Yeah. So are you guys actually designing a data center with enough spare capacity to take over the load of the other one?
Yes. So the question was, do we design the data centers with enough spare capacity to take over the load of the other one? Yes, we do. There's more than twice as much capacity in the system so that they can both take the load. The other thing that we do that is somewhat related is that both the data centers are active at any given time, which means that when someone connects, they don't know which of the data centers within the region that they're connecting to. Roughly half the connections are distributed throughout. So another principle that we follow, and I talked a little bit about the Mother's Day type of scenario before and back to school, is we do reorganization. So the system will actively load balance in order to restructure the system against extreme load. So if there's some extreme spike in load, and this doesn't necessarily have to be some known cause. I mean, back to school and Mother's Day, these are things we understand really well, and we can take other methods like deploying additional hardware and so on to protect against them. But the system itself will actually redistribute the load in order to make sure that a spike in load due to some unforeseen circumstance. Another type of situation that this happens in is if there's a virus. So if there's a virus that's causing a lot of mail to hit FOPI, Forefront Online, for instance, the amount of Forefront Online load increases a lot. And Forefront Online is structured so that it actively load balances it, smooths it out so that all of the servers, you don't end up having servers that are particularly hot. It's also one of the ways we respond to hardware failures. So if you have multiple servers that go down, so most of you are Exchange guys. One of the things that I realized when I was a high availability PM is that the placement of the databases within the database availability group is really, really critical, because once you lose a server, you can end up losing a server, and if you don't design the layout of the databases perfectly, then you end up with spikes in load on certain servers. And then if you end up losing two servers, if you have a fairly long replacement time on the server hardware, if you end up losing two servers, then you end up having this cascading failure where you lose a large number of servers, every server with a copy of those databases that ended up losing 2 copies. And we do a kind of active load balancing by structuring the databases so that individual server failures will result in the databases being distributed throughout the DAG in order to make sure that these hardware failures end up having a well-distributed load. So another principle that we follow is human backup and human in loop. So we have multiple layers in the monitoring system. The server software, of course, tries to fix problems that occur within the high availability systems, but sometimes they get into pathological states, and you need an external agent to be able to go in and fix those problems. So we have a monitoring system tied to an automated workflow that goes in and tries to resuscitate the system, essentially. So if there's, I was talking to this gentleman here before about transport queues. If you have transport queues in your Exchange server, the automated workflow will go through and try and take recovery actions, and including restarting the transport service, restarting the server that it's on, and it'll take all of these actions. But at the end of the day, if it can't figure out how to solve these problems, the engineers get paged. So when I was in the high availability team, there was a point at which my team, members of my team, we were on a weekly rotation. We get paged 20 times a week from the servers that had gone down, had lost disks, and so on. And in order to come through and fix those problems, we'd have to take manual actions. I can tell you that it took us less than 3 months to go from 20 pages a week to 2 pages a week, because the first thing that we did when we were woken up 4 or 5 times during the night over the course of a week is go back and figure out how to solve that problem. So because the on-call engineers are the core product group members, the ones that design the product, we make sure that we're not only taking the feedback that we get from the monitoring system and the things that fail, we make sure to design in other automated mechanisms by which we can restore service. And the side benefit to that is not only is the server and the service designed in a more hardened fashion, but the response time of the automated system is much, much better than a sleepy engineer. So our ability to recover from these problems gets better and better over time. And I can tell you personally that that has happened. The other thing that we need in order to make sure that we're able to take these actions is that we have detailed logging and tracing. I mean, the thing that frustrates you the most is if you get woken up in the middle of the night and you get paged and you don't have enough information to figure out what that problem was. So because of this human in loop, we have detailed logging and tracing so that we don't make assumptions when there are problems. We understand what's going on in the system. And there is very, 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 very good detail, both in the service and in the server, because as you all know, we're actually running exactly the same server software in the services that we offer on premises. So if it's Exchange Server 2010, we've got Exchange Server 2010 in the service. If it's SharePoint Server 2010, we've got SharePoint Server in 2010 in the service, and so on. I mean, any deviations from normal behavior that we see, they also send these alerts to on-call engineers so you can collect the information at the time the problem is occurring and rapidly resolve it. So first, the on-call engineer resolves the problem. The next thing, they open up a bug, put all the information in, and then go to fix the problem. So it's a very, very efficient way to have this virtuous feedback loop so that these problems get fixed and the resolution of these problems gets faster and faster. So another thing that we strive to do, and to some extent this is at odds with the principle of functional redundancy, is we try to avoid complexity within the system. By having standardized hardware and an automated deployment model, I mean, if you look at low-cost airlines, they actually have the same model of airplane throughout their fleet in order to make things operationally efficient. And the same principle follows here. If you have the same model hardware and the same deployment model everywhere, it makes things very operationally efficient and very easy to diagnose. And we do have a bit of a tension between them, but at the same time, we tend to have standardized hardware. We have an automated deployment model so that it's very, very easy to deploy additional servers in the case of spiky load and so on. We also look at context-spanning problems. So we test each of the recovery scenarios on a regular basis, and that actually includes data center failures. So when I say we have more than twice as much capacity within the two data centers, this is something we've actually verified, and we verify continually on a regular basis. And the reason for verifying it on a fairly regular basis is if you push new code, you push new configuration, there may be unforeseen ways in which you can have a failure to recover. And only by testing it out can you really discover what these issues may be. So all of these things are tested on a regular basis, including regional disasters that would take out a data center. We also follow the principle of service component isolation, so that if we have the case of a server being overloaded, it's not going to end up cascading that failure all the way through the database availability group. We're going to make sure that that failure is actually isolated to that particular server. Another principle we follow, and this is not necessarily particularly intuitive, is that of graceful degradation. So I'm assuming most of you know about run flat tires. So the principle here is that if you have a car and you're going down one of the highways at 160 kilometers per hour, that kind of thing, and you have a flat tire, you don't necessarily want to be in the middle of the highway running at 0. You want to be able to at least slow down and run at a reasonable speed so that you can get to somewhere safe and you can replace the tire. And this is another one of the principles that we follow, which is that the service should gracefully degrade. We don't want catastrophic, you have no functionality. At the worst case, it should be, slower at sending mail. It's better than completely losing the ability to send mail. And that's, again, one of the principles that we follow to avoid catastrophic impact. So I'd like to take a couple of minutes just to take a couple of questions so that we don't have all of the questions at the end in case there are any. I know I've gone through quite a bit here. Anything? Okay. Go ahead.
What kind of database availability groups are you using between your data centers? Are you using stretched DAGs?
So the question was around.
One data center and you just use storage mirroring.
So the question was around, are we using stretched DAGs? I can answer that by saying, we have used in the past, and we will probably continue to use in the future, DAGs that are stretched across multiple sites and multiple data centers. We do use that because that's the functionality that's built into Exchange 2010. But in terms of the exact architecture, I'm actually not even sure what the exact architecture is and how those DAGs are stretched across data centers, because what was there when I designed the system has changed quite a bit since then. Does that answer your question? So let's go ahead and talk about the numbers and talk a little bit about how these numbers translate into your organization. Because, I mean, to some extent, you don't really care what the overall number is. If it's 3 nines or 4 nines, it doesn't make a difference if your CIO or your very important customer is down. So you can have near 100% availability, but if your very important customer is down, it doesn't do any good for you. And this is something that we can talk a little bit about how that can be the case. So looking at the service level agreement, we've got an expression of uptime in terms of user minutes of uptime, total user minutes in the month, and total user minutes of downtime, and it's expressed as a percentage. And this is a pretty useful expression for the service level agreement itself, because if you look at it, the characteristics of the equation are longer outages means you have a greater impact of the percentage, and in terms of the money we give back to you, it makes sense that if you have a longer outage, we should compensate you more. Outages that affect a greater number of users also have a greater impact of the service. And again, this is desirable because, if it's one user out for a couple of minutes, it's less of an issue than 1,000 users being out for a couple of minutes. So if you have more severe outages in terms of users or duration, you're going to have a greater deviation from 100%. And this is good for an SLA. But what people who run cloud services and who tend to report on cloud services tend to do is they take that SLA expression and they express it as an aggregate uptime. So you take user minutes of everyone in the service, you take downtime user minutes of everyone in the service, and then you express that as a percentage. And the objective there is to convey the risk of an outage to an individual customer based on this big aggregate uptime. So tens of millions, you've got tens of millions of user minutes within a month, probably more than that. You take those numbers out and you express it as a percentage, and that is supposed to convey some sense of the reliability of the service. The problem with this is that it's not really a particularly good expression to use when you're describing the uptime of an entire service. So for instance, if you have downtime that's not dependent on the number of users, you're still adjusting it by the number of users that went down. So for instance, if I have a database and it has 300 users in it, it's a database that's down. It doesn't matter how many users are in that database. So if I'm trying to give you an expression of what the risk is, the risk shouldn't be adjusted by 300 users. It should be adjusted by one database, because whether it's 300 users or 3,000 users that are in that database, it's that one database that's down, and it's a cause that caused that one database to be down, if that makes sense. So it's still adjusted by the number of users when you have this really simple expression, which means that you're mismeasuring the risk that is due to that particular outage. The other thing is, if you look at that expression, the overall aggregate uptime percentage is heavily dependent on what your definition of downtime is. So, for instance, Exchange Online has no planned maintenance. There's absolutely no downtime that is used for maintenance and so on. Where some other services like SharePoint Online, they have planned downtime within them. So if you exclude that downtime, it's very heavily dependent on what you consider downtime. So in SharePoint Online, you take out planned maintenance. In other services, they may consider a specific number of users. They can say, anything under 5% of users, we don't consider that downtime. So when you're comparing across services, when you're trying to compare the aggregate uptime of these services, it's very, very heavily dependent on what that cloud provider describes as downtime. So that's something to look very, very carefully, whether you consider Office 365 or Azure or Dynamics or any number of competing services. You want to be sure that you're comparing apples to apples when you compare the uptime percentage. The other thing is different cloud services provide different functionality. And this is something that's not particularly intuitive. So let me take an example from Exchange, because I understand Exchange, and it looks like most of the audience does. If you, for instance, have an issue with Exchange Mail, Exchange Calendaring, and Exchange Tasks, let's take those three, and you've got issues in all three of those during the month, each of them has a 5-minute outage over the course of the month, affecting all users in your organization, let's say. So if you put it together, because the functionality is combined into Exchange, you have 5 minutes in each. You've got 15 minutes downtime multiplied by the number of users for the entire month. Supposing there's a cloud service that has those things split up. So tasks is 5 minutes, calendar is 5 minutes, and mail is 5 minutes. That means each of those services only has 5 minutes of downtime during the month, even though combined together they have 15 minutes, which means that the uptime percentage for each of those services will be higher. Even though if you combine them together, you have 15 minutes of downtime, and that's what's reflected over the course of the month. You separate them out, it's 5 minutes of downtime for each, and they're now all looking better. And this is something that we have not made a particularly strong effort to try and manipulate those numbers. So Exchange functionality is Exchange functionality, and it's got all of the downtime is reported together. But if we chose to do that, we'd be able to provide you with a more attractive looking uptime number. So when you go to cloud providers, you should be really skeptical of the services that are bucketed together. The last point, and I think this is the most important point for Office 365, is that the productivity loss due to downtime differs by service. When we designed Office 365 and we designed the Office stack, we designed them so that you have multiple points of functionality that's provides resilience, which means that if you're running Outlook and your Wi-Fi goes down, you still have productivity. If you're running Outlook and your server goes down, you still have productivity. It may not be the same level of productivity that you would have if your server was up or your Wi-Fi was up, but you still have a level of productivity. Whereas supposing you were only using Outlook Web App and you were using Outlook Web App alone, then the productivity loss due to using Outlook Web App alone is more than you would have if you were using Outlook. So depending on the service, if it's a pure cloud service to some extent, it's more vulnerable to these types of service loss than something that has a hybrid type of character to it. So again, I want to make sure to take questions as we go along. Are there any questions about the numbers? Okay, great. So let's go ahead and jump into what happens during an outage. So we've put a lot of effort into communication. We got the feedback from our previous BPOS days that communication is something that our customers really, really want. We want to provide a rich communication experience for what's happening with the service, whether it's in terms of things that we are planning to do, things that we're planning to change, and so on, and whether there's an outage. And we provide notification of all of these whether it's planned maintenance or service alteration or incidents, we provide notifications for all of these. For planned maintenance, it's typically 5 days, I believe, is the requirement that we provide information to you 5 days in advance. For service alteration, for instance, if we're changing service features, changing capabilities, most of the time these are adding capabilities to your service. We typically provide that information 30 days or more in advance. And if it's a major capability change, such as you would expect between major versions of the server, you are generally given a window in which you can defer those upgrades. You can say, well, for BPOS to Office 365, customers were given 12 months to say, you know what, I can't afford that disruption to my end users at this point. I need to be able to push it out for 3 or 4 months so that I can prepare my end users for that. And this is something that as a company and as a service, we strive to provide that level of notification so that you can set expectations for end users. Notification for service interrupting events is typically within minutes of the service interrupting event itself. And notifications of milestones in subscription, it's typically around when your account lifecycle is expiring. So if you have a number of accounts that are running out of service, if you've signed for a year, typically we'll notify you a month in advance that this is going to run out so that you can take action in advance to prevent that any interruption of service. We also provide these information through multiple modalities. Some of these things are provided through customer email, like for instance, account lifecycle. Obviously, you don't want it put on Facebook or Twitter. But on the other hand, things like a service incident, we want to make sure that you're able to access it in whatever way that's most convenient. So we publish these things to the Service Health Dashboard. They're published to the community. We have Twitter and Facebook pages in order to make sure they're published there as well. So we're striving to have as many convenient communication modalities as possible so that you are notified of these incidents prior to end users. I mean, the last thing we want to have happen, and that's the feedback that we got, is that IT administrators and they don't want to hear from their end users that there is a problem before they hear from us. So we're striving to make it as easy as possible to get these updates. So again, I've mentioned it a little tangentially, but we also strive to have the most responsive support and to have a comprehensive financially backed SLA, which means that we compensate you within the terms of your service lifecycle rather than adding days onto the end of the contract. And we do this not only because this is something that our customers, you guys, have asked for, but because this motivates us in some ways to make the service better and better. I mean, there's a financial cost, there's a bottom line cost to us every time we have a service outage. And I can tell you when I have a conversation with my VP, and he tells me, look, this is something that's really important. What's going through his mind is this is costing us tons and tons of money, as well as not being able to provide the kind of service that we want for our customers. And this is something that we've strived to make better, and I think we've done a pretty good job. We've exceeded what our SLA has been in aggregate. So to talk a little bit more about how the service incident communication flow works, once we have an incident where the on-call engineer is paged, they once they realize that this is an issue that affects a certain level of tenant and across component areas, and it's not something that they would be able to fix within a short period of time, they escalate this to a full incident team. And then once the incident team gets engaged, there's ongoing communication throughout the course of an incident. I believe, and don't hold me to this, but I believe we actually communicate every couple of hours what the status of an incident is, however long that incident is. Or in most cases, the issue gets fixed sooner than that, in which case we post on the various Facebook and communication channels that the incident has been resolved. And then there's a post-incident wrap-up. So both immediately after the incident and 5 days after the incident, there's communication as to what the root cause was, what actions we're taking, and the actions that we're taking in the future to make sure that this type of incident doesn't happen in the future. So I talked a little bit about the communication channels. There's also an RSS feed so that you can look at the service incidents in an RSS reader. And the post-incident review is the communication that I referred to that's 5 days after the incident that lets you know what happened, what the actions that were taken, and what actions will be taken in the future. So let me talk a little bit about the incident team itself. So I know the description on the side says IMs are on-call engineers. Actually, it's a little more than that. Incident managers are part of the engineering team, and they're typically dev managers or group program managers. They're typically engineers that run organizations of 20-ish people, so that they're able to provide their expertise in running a team of this size to quickly determine the scope of the outage, determine root cause, and make sure that the action that could be across multiple component areas, that the action is taken in a quick and coordinated fashion. So it's not just that they have deep expertise in a particular area, it's that they have expertise in a particular area and are able to provide expertise in running the incident team. Again, similarly, communications managers are on-call engineers, but they're specialized in communicating. So it's, if you know anything about the typical Microsoft developer or typical Microsoft program manager, communication is probably not their strong point, and you don't necessarily want them to be the ones that are communicating out to you what the problem was, what actions that we're taking, and what we understand of the problem. So there are people in the writing team, in the tech writing team, in the customer experience team that are specialized in understanding what these problems are. They get communication from the core product group members, and they're able to communicate effectively what the problem is, and they coordinate this communication across the team as well. In addition to that, there's support channel. So when you talk to your Microsoft support person, they actually have a full view of all of the internal information that they can provide to support you, and they monitor these support channels on a continuous basis in order to understand what outages may be happening and the specific customers that are affected for that. So we also have a fairly detailed taxonomy of what the service incident status is. As soon as we realize that there's an outage, in fact, in some cases, the automated monitors will actually change the status to investigating as soon as an engineer answers a page. And then once the outage is confirmed, it would be classified a service interruption, or in the case of a service degradation, degraded service. Once the cause is determined, the communications manager updates the status to restoring service or extended recovery if there's a backlog of items that needs to be cleared. And then once service is fully restored, it's service restored status. So I kind of went ahead and described how this works, the flow of this. The incident occurs, it's updated to investigating. The status itself is posted to the service health dashboard, and it's continually updated until the service is restored. And then once the service has been completely restored, that status is posted, and then within 5 business days, there's a post-incident review. So can go ahead and skip through this. This is a similar type of information. Were there any questions on the support lifecycle? Go ahead.
You mentioned a lot of ways how to secure the services. Our customers are also interested in the data.
Mm-hmm.
Could be erased by accident, by virus, could be can get lost or by sabotage. Do you have any ways to back up the data or to restore deleted data?
So the question was, I talked a bit about how the data is mirrored effectively, and I didn't talk as much about how data is backed up. Does that? So that's something, that's another principle that I did not mention. We do effectively have backups of data that are point-in-time backups of previous time. It's not something that we can, if a customer requests that data to be restored, that's not something we can typically do. But in the case, we do have this backup in the case of potential code bugs that can destroy all of the replicas of the service and things like that. We do have the ability to go back to a point in time in terms of that type of mass destructive type of action. Does that answer your question? Any other questions? Go ahead. What happens to the data after unsubscribing? I have to say I don't know specifically. I have to say I don't know specifically what the period of time in which the data would get overwritten is, but it will get overwritten. Correct. Correct. So we will allocate that space to a different customer, and it will get overwritten. I mean, the way it works in Exchange is we'll continue to use those databases, and when the storage engine goes ahead and sees that the space is free, it's going to try and allocate things to that. There is data scrubbing as well. So in Exchange, data that's deleted will get zeroed out, and there is some period of time that it takes to zero that data out. So, in terms of SharePoint, I know that we reallocate that space, but I'm less familiar with how long it takes for that space to be reallocated. But we don't retain the data after a tenant is deleted. Go ahead.
If my understanding is correct, you are not able to restore specific records for a user?
There.
I guess that the only capability that we have to restore some deleted emails by error are to use recover deleted items. How many days is the dumpster in this case?
I'm not sure what the specific recover deleted items dumpster is set at, but there is a mailbox dumpster as well. So even deleted mailboxes can be restored through mailbox dumpster. I mean, again, this is Exchange functionality that's basically provided through the service. But it's identical to the Exchange functionality. There's nothing specific to the service that we provide. I mean, if you have an on-premises server and an admin goes ahead and deletes those mailboxes, if you're running without a point-in-time backup, it's very difficult to restore. And even with a point-in-time backup, it's somewhat difficult to restore a deleted mailbox. Go ahead.
What are the default settings to restore some information? For example, a customer deletes all emails for 2 months, and he needed that information.
Mm-hmm.
Can we open a ticket and Microsoft has the capability to restore that information?
So the question was around restoring data, whether it's possible to, for instance, recover deleted data after 2 months. If the mailboxes are on legal hold, then yes, you can go ahead and undelete those items. But in general, it works exactly like an on-premises server would. We don't have any specific capabilities to go in and restore data. It's not really the way we've designed the system to infinitely keep infinite point-in-time backups. The point-in-time backups are generally to protect against widespread types of corruption or bug types of issues. It's not really to protect against admin error. And there are mechanisms that are built in to protect against admin error. You do have the mailbox dumpster, you have deleted item recovery, you have legal hold, and those mechanisms that you have for on-premises servers, you also have those for the service. But it's not really the backup that we have. It's similar to a lag copy in that you don't really want to turn everyone back in time for recovering a deleted mailbox. Any other questions, or I can move on to the next section about how we differ from our competitors. So, I mean, one way that we differ from our competitors, and the reason for our different approach here, is that productivity is really our core business. It continues to be our core business, and Office Division produced over half of Microsoft's operating income. We're really in this for the long haul, and we're really in this to provide a productivity experience that's as available as we can possibly make it. And you see that reflected within the design of the Office software stack. You've got Office Pro Plus, and it's vulnerable, or it provides resilience against vulnerabilities to cloud disruptions. If we have servers that go down, it provides protection against that. But it also provides protection against network interruptions. So if you have flaky Wi-Fi, I was in a hotel that provided very, very intermittent Wi-Fi service, so intermittent that I could never see Outlook Connect. And if I was trying to use something that didn't have that level of functionality, there's just no way I would have been able to use it. On the other hand, I left Outlook running. I left it running overnight. And 3 a.m. or something like that, it connected and pulled down a bunch of messages. And I was actually able to, first thing in the morning, check my messages, get almost all my messages, respond to messages. I was able to have that productivity experience. And without this resilient stack, I would not have been able to have that. And the same is true in if you're on the go. We provide active sync functionality that's pretty much ubiquitous in most phones out there. We provide a way for you to continue to be productive even on an airplane. I'm kind of spoiled by domestic travel that we have Wi-Fi on planes, and in most cases, the Wi-Fi on planes has been more rock solid for me than it has been in hotels. But on a transatlantic flight, I don't have that. But at the same time, if I want to stay productive, I can still use Outlook and SharePoint Workspace. And this software stack provides me with the ability to be productive wherever I want to be. The other thing that this is reflected in, our SLAs are written with more than just login. And this is something I didn't talk about earlier when I talked about comparing the uptime numbers or the downtime numbers. But the definition of downtime, it's more than just the server-side error rate. It's more than just, can we connect to the server? Is the server alive? It's, you need that real functionality to be covered by the SLAs, and you need that functionality to be understood by the organization. Can you read data? Can you write data? Can you send and receive messages? Can you actually have IM conversations? That's the kind of thing that you want our SLAs to be written, and that's the thing that we've done. We've taken those functionalities into consideration, and our SLAs are written in such a way that says that we're providing that functionality, all of that functionality, with the uptime percentages that we promise. Also, it's every user. So we understand that even one user outages can be pretty bad, depending on who the user is, and somehow it's always that bad user that ends up having issues, and that user that is complaining a lot and is one of the C-level officers of your company. You can't call support and have them say, well, you know what, it's not enough users for us to really escalate up as much as we can. Support and our agreements, it refers to all of our end users, not just that a number that exceeds a particular threshold. The other thing that we do is, and I talked a bit about this earlier, we test this stuff. We test our recovery time, we test our recovery point, and the things that we promise in our service description, the things that we say we do, they're based on this regular verification and with a little bit of slack time even, because we understand that if you have a mock disaster, people are going to do a little better than if they're really in a stressful situation. They understand that thousands of users are out. People do better in a mock disaster than they do under those stressful conditions. So this is actually a worse time than we would typically expect to have in a real disaster. And it's not all of our competitors are as diligent about what they claim. We're trying to be as transparent as possible so that we can exceed the expectations that you set, not set the expectations as high as possible and figure out what happens afterwards. So I'll jump into how we are trying to make it better and why I think this continuous improvement process is going to continue to get better and better. I mean, first of all, Microsoft is committed to cloud productivity. It's a core business for us. Steve Ballmer on down is committed to it. I've seen emails when I was in the Exchange Online high availability team. I've seen emails from several of Steve Ballmer's direct reports saying, what happened here? Big red capital letters. I've seen these emails. And that's the kind of pressure that we have for continuous improvement. Microsoft is really committed to this as a business, and it's from the executives on down. And actually, we're doing pretty well. At the end of our 1-year anniversary, it's one of the most reliable services that are out there, and we're doing pretty well in terms of providing an availability experience. But we also acknowledge that it's not perfect, and we have a regular cadence of continuous improvement. We actually do, in the background, we do bi-weekly service updates. And this is probably more often than you would expect or even see as a customer, because these biweekly service updates are completely transparent to you. You never see them. They actually happen behind the scenes. And for availability, typically this is the kind of update in which availability improvements happen, whether it's deploying additional recovery workflows, or whether it's making small improvements to the way the product works in order to make it more measurable or stay up more often. We also do package it in with feature and capability releases every 90 days. And these are typically small things that may be end user visible. We don't want to change the end user interface all the time. It's disruptive, and it's not something that is very conducive to end user productivity. So those are typically every 90 days, and those are somewhat akin to service packs for the on-premises servers. And then we have major feature and capability releases every 12 to 24 months. And this is something we've committed to, and these are typically large end user facing changes. I mean, you guys have seen the kind of changes that are there in between Windows 7 and Windows 8. That type of change is not something that we want to do lightly, and it's something that we want to package up and do together so that you have time to train your end users so that it's not a productivity disrupting experience. So this is the reason to have a different cadence for those types of changes. And we're not planning on stopping. I mean, I know that availability is continuously something that we're working on. We're continuing to work on. We're improving it. Support, the service incident experience, is also something that we continuously get feedback on, and we strive really hard to make it better and better. We're also trying to figure out ways, and we're taking feedback on how to make our SLA better to better reflect our commitment to meet your needs. So we're not planning on stopping this. We're in it for the long haul, and this is something that Microsoft feels is a strategic direction. And we're really committed to making sure that the service stays up. And it's engineered for reliability from the ground up. We're trying to provide as much communication as we can around the service. And we're trying to improve it on a continuous basis so that you have the best service availability experience possible. So that's all I had. I'm happy to answer questions if you have them. Go ahead.
Can you communicate about the architecture which is behind
So there is some description of architecture within the service descriptions, but beyond what's in the service descriptions, we generally won't. And the reason for that is because the architecture typically will change in those 90-day releases. It's not necessarily stable for any particularly long period of time as we understand more and more about how to get better availability from it. So I know even in the last year, the high availability architecture has changed. And this is in response to an issue that we had middle of last year. So we don't typically communicate those because we can't really, when we communicate that to you, we're kind of promising to keep the architecture stable. And we can't continue to meet your objectives and keep the architecture stable. The other reason we don't typically communicate that is because we generally try and do a best of breed approach in terms of architecture, where the Exchange architecture is designed in the best way possible for Exchange, and the SharePoint architecture is designed in the best way possible for SharePoint, and so on. And it's not necessarily something that provides a coherent picture of how the service is architectured if we give you these separate pieces. I mean, it does make sense to each of the product groups, and it makes sense in terms of what we would like to achieve in terms of service availability, but it's not typically something that we would try to provide. Any other questions? Go ahead.
What are the RTO and RTO times for 365?
I didn't provide values. It's actually in the service description. My understanding is that the RPO is RPO is 0, and the RTO is 20 minutes. But the service description is the authoritative place to look for that information, and it does get updated as our capabilities improve. Go ahead.
With more sites moving towards federation, would you still be able to sort of provide 3 nines, or will you have to sort of amend the SLA? Because obviously you could be up with the federation service down at the client side, but their director could be logged into email and all he can see is I can't get my email from 365.
Understood. Yeah. So the question was around federation and whether we'd be able to continue providing 3 nines. My understanding is that the description will be written dependent on that federation server being up. I don't think we're changing the availability numbers as such, but that's something that we expect the federation server to be up. Otherwise, you can't really log in. Would we have a way to proactively monitor federation from our end? I am not aware of any plans to do that at this point. But the way we would end up doing that if we did it would be to provide a way for the customer to monitor their own server through our services. We wouldn't typically. I mean, if you think about it, if we get paged, if Microsoft gets paged for a federation server issue, we can't really do much about it. So.
No, I was thinking about just the reporting, so that if there was ever.
Oh, I understand. For the.
Coming to you and saying we've been off for 5 days, we demand X amount of money. You've got stats that say, well, we've been up, but we can see that if there was an issue with your federation, or we couldn't contact the federation server.
Understood. Yeah, I don't think we currently have a way to monitor that in terms of reporting purposes either. But it is an interesting idea. Any other questions? Okay, well, thank you all for coming, and I hope I've answered everything you needed. Thanks.